Okay, so I've got my 12 items and I've gone for 12 potatoes. And we are looking for factor pairs. So what we're going to do is arrange these 12 items, these 12 potatoes, into as many different arrays as we can. So what I'm going to start off with is 12 by 1, because we know that every number is in the 12 times table. And we're going to have enough room here to put 12 potatoes in one long line. Yes, I do. Perfect. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 potatoes in a line of 1. So 1 and 12 are a factor pair. Okay, what shall I do now? Maybe I'm going to put it into 2 equal rows. So this time I'm going to take my 12 potatoes and I'm going to split them into 2 equal rows. So I'm going to start by doing this, and I'm going to put 1 potato in each row until I have run out of potatoes. Now, if you remember how arrays work, I count the side and the top. So this is 2 by 1, 2, 3, 4, 5, 6. This is 2 by 6. So another factor pair is 2 by 6. Let's check that. What is 2 times 6? 6, 12. Okay, now I'm going to put it into 3 rows. So I'm going to have 1, 2, 3. And again, I'm just going to equally share out my potatoes, or whatever 12 items you're using. Brilliant. So have you put your 12 items into 3 rows? Then count with me. How many do you have in each row? 1, 2, 3, 4. So we have 3 by 4. Shall we check? What is 3 times 4? 3, 6, 9, 12. Brilliant. Now, if I were to put this into 4 rows, what would be the factor pair? Well, let's have a little look. So remember, now we're going to use the number 4 as one of the factors. So this time I'm going to start with 4 down one side, and I'm going to equally share out my 12 items between those 4 rows. Now what have I got? I've got 4 and I've got 3. 1, 2, 3, 4. 1, 2, 3. But have I already got that factor pair? Well, yes, I have here. Okay, they're around the other way, but I still have written this pair of numbers down, so I can't use it again. Is 12 in the 5 times table? Because that's the only one we haven't tried yet. Well, let's check. If it's in the 5 times table, then we're going to be able to make 5 equal groups. So again, I'm going to put my potatoes into these 5 groups. But look what's happened. I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But 2 left over. I have a remainder of 2. Therefore, is 5 a factor of 12? Well, no, because 12 isn't a multiple of 5. It's not in the 5 times table. Next would be 6, but I've already done 6. 6 is there. So I know from using the potatoes, from starting with an equal group of 1, then 2 equal groups, then 3 equal groups, and then testing 4 equal groups, I know I have found all the factor pairs. Because 5 doesn't work, then it would be 6 and 2. 7, remember, is a prime number. Is 12 in the 7 times table? No, it's not. Is 12 in the 8 times table? No, it's not. Is 12 in the 9 times table? No, it's not. In the 10s? No. 11s? No, but it is in the 12s. You cannot get a factor which is greater than the multiple which we're looking at. So remember, we are looking at 12. Therefore, I cannot have a number that is greater than 12. To check, we've got to make sure that they times together to make 12. 1 times 12 is 12. 2 times 6 is 12. and 3 times 4 is 12. Remember, times tables are commutative, so just swapping the numbers over doesn't count. Therefore, there are 1, 2, 3 factor pairs of 12. So now you've done that with your items, what I want you to do is head over to the slides, thank you Tobias, fill in what the factor pairs of 12 are. I want you to fill it in on this slide and on this diagram, and then try using 8 items. So this time I'm going to take 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to get rid of these 4 because 12 take 4 is 8. And let's see how many factor pairs you can make with your 8 items.